functions. I'm going to try to keep this at the Algebra 2 level this year. So I'm going to try to keep the calculus actually super minor. So we're going to be working with the derivatives of inverse functions. So the first thing I want to talk about is what inverse functions are and what they do. So when you had Mr. Michener in Algebra 2, you would have worked with what are called inverse functions. He probably told you that if 3, 5 is on the original function, what point is on the inverse? 5, 3. The x's and the y's swap out. And maybe you even had to find some by swapping them physically and solving for the other one. We're not going to be doing that. We're going to be finding the derivatives of inverse functions. But remember that inverse functions actually undo each other. So if f of x and g of x are inverse functions, then when you put one inside of the other, they undo each other. And likewise, if you put them in reverse, they undo each other. That's just what inverse functions do. They basically undo each other. For example, if I were to say I have the function x squared, and I called that f of x, and I had its inverse function, which I'll call g of x, which would be the square root, because those two things undo each other. When I compose them, what I mean is, if I put x squared into g, I'd have the square root of x squared, and then x would pop out, correct? If I put root x into x squared, I get an x. They undo each other both ways. It says ways you'll know that functions are inverses. Number one, you'll be told. It'll say g is the inverse of f. It'll actually physically say it. Number two, you'll have notation for it. And the notation for an inverse function, like the inverse of f would be written as f inverse, like this, of x. So you'd be like, oh, that's the inverse function with notation. Or it'll give the actual meaning. There's one in one of our examples where in the stem of the problem, it says this. And you're supposed to infer, okay, these are inverse functions. So there's 3 ways you'll know you're working with inverse functions. Most of the time, especially in the AP exam, they'll just tell you h is the inverse of f or something like that. A lot of times there's notation. This is the least common. So I'm going to give, there's a rule for it. Do we like rules? Sometimes. I'm going to show you the rule. I'm going to derive it, so I'm not just plopping it up on the screen because you should understand it. I don't even have to wait to tell you where it's coming from. But then I'm going to not use it. And it worked great last hour. So here's the calculus rule. But we stopped with Algebra 2 and they were killing it. But I do teach calculus, so here's the deal. If functions are inverses, so let's go ahead and break this down again, they undo each other. That makes sense, right, Lulia? My goal is to find the derivative of the inverse function. That's our end game today. We're going to be finding derivatives of inverse functions. So what I'm going to do is take the derivative of the left and set it equal to the derivative of the right. That's pretty easy. What rule will I use on the left? Chain, yeah. So the chain rule says formally you take the derivative of the outside function, don't touch the guts, then times the derivative of the guts. So the left hand, this derivation of the rule is really easy. It's just the rule is cumbersome to use. What's the derivative of x? If you don't know that, you're voted off the island. And then my end game is just to figure out what g prime is. Well, g prime would then be 1 over f prime of g of x. That calculus makes a lot of sense, doesn't it, Josh? I mean, it makes sense. A lot of times, though, that g of x, they'll write it as, so it'd be f prime of f inverse of x. So you'll see that a lot. It's easy to derive, but do you understand what it's giving you? Or are you like, oh, that's a nice rule, right? I'm going to show you the delta math solution, because delta math is programmed to do it this way. I'm going to program you to not do it this way. So what's going to happen is if you don't understand the delta math, you're going to have to ask me or somebody next to you. All right? Because you wouldn't find this method even if you Googled it. I made it up. It works though. Okay, so I've been struggling with this lesson for 10 years, and I'm like, I'm not doing it with calculus anymore. This is, I hit show solution, and this is what it's telling me. Does this make a lot of sense to you? Look at that. Does that make sense? Or does it look like a lot of notation? A lot of notation and kind of cumbersome, right? Like with the inverses and the primes, and I've got the negative and a -1 and a prime symbol and a 1 over it, and what the heck's going on? It's actually a super easy concept if we don't do it this way. So do you guys trust me? We're not going to do it this way. The only thing is if you don't understand it, you're kind of stuck. So you really need to listen, and I think that's last hour they were totally listening, and so they were like, okay, and then they just cruised. Couple needed help from somebody else on the Delta Math, but everybody left the hour being completely done. All right, so just know you'll get there if it's not right away. Here it is. It says this rule, although very true, this is truly how you do get the derivative of an inverse function. It's super accurate. It almost always gets forgotten. Like even if you were able to do that today, even in like 2 days, when are we going, what's that rule again? It's not like Lodi, Highlands High. It's hard to remember it. So I'm going to demonstrate what happens with inverse functions and why my method works. Okay? So I guess I should publish this method because it worked last hour. I was like, sweet! I thought of something new. Go ahead and go right here. All right. So we're going to talk about inverse functions. Let's use those two we just did. I said f of x equals x squared. I'm going to kind of go dotted over here because I'm going to work in the first quadrant. But there's my first function. Let's write it in red right here. F of x equals x squared. That's my original function. What's its inverse function going to be called? Square root. Yep. So I'm going to call f inverse of x would then be the square root function. I know those two. I'm going to use it I'm going to demo in red here and blue. That would go like this. Pretty decently, correct? I'm going to put our end game down here, like what you're going to be asked to find. I'm going to give you a couple points on each of these. I'm going to go up here. I'm actually going to stretch this out a little, my parabola up a little higher. All right. So first thing we're going to talk about is what I call corresponding points. At 4, you would be on this blue one at 4, 2, correct? On the red one, what would its corresponding point be? 2, what? 4. This is what I'm going to be talking about in my method when I talk about the first thing you need are the 2 corresponding points. Okay? So you're going to have a point on the inverse. Your end game is going to be to find the derivative here. Does that make sense? On the inverse function. So your goal is going to be to find the derivative of the inverse function, and let's say at 4. Because I can see it, I mean, it's pretty straightforward, but I want you to see the relationship here. Are you ready? What is the slope of this tangent line? You should be able to do it in your head. What is the slope of this black tangent line? Slope of the tangent line is the derivative. What's the derivative of x squared? Twice x. At the point 2, 4, what would it be? 4. Right? So my derivative on the original at 2 is equal to 4. How do I know that? I just took the derivative. It was an easy one. Watch my derivative on the inverse function at the corresponding point. Watch what happens. What's the derivative of the square root of x? 1 over 2 root x. Yeah, that one's popped up a lot. At 4, what would it be? 1/4, correct? So my derivative of the inverse function at its corresponding spot was equal to 1/4. Look at these two numbers. What do we call those in math? Reciprocals. And it makes sense why they'd be reciprocals, because didn't your Algebra 2 teacher say that for inverse functions, the x's and the y's swap, right? So aren't slopes y's over x's? So would their inverse functions be x over y's? Would it flip? Doesn't that make sense? Like logically, I don't really need calculus to understand that if the slope on one of them, if the x's and y's swap, it's just going to flip my slopes. So that's the first concept I want you to know. That we have to have corresponding points. You'll be able to find them easily. So you will not stress at all. You're going to find the derivative on the original function, and then you're going to flip it. And that's all you're going to do. So I'm gonna be talking about your algorithm is gonna be point, derivative, flip. That's all I'm gonna have you do. Okay? So the goal today is gonna be to find the derivative of an inverse function. It is a reciprocal. You are just gonna be flipping a number. You just have to walk yourself to that number. And I'm gonna practice walking 6 different ways. They're fast. They're like, it's not like implicit where there's so much work to do. We're gonna start, we're gonna do 3 kinds. This kind I would call analytic or algebraic. I actually know the function. This kind I call tabular, and then the other kind I call like pre-measured bowls, like a cooking show. Like they give you all the ingredients, you just kind of have to dump it in. Here's what we're gonna do. We're gonna make 4 bullets because it's a 4-part algorithm. It's fast. And you're gonna think about what you're doing. My goal, we'll box this in, is to find the derivative of the inverse function at x equals 1. Put a little x here. That's an x value. Do you agree with me? And it has to be the x value on f inverse, because that's where I'm finding the derivative. So you're gonna start like this and say 1 comma something has to be on the inverse function. Can't find the derivative there, there's not a point there. Then you're gonna go to point number 2 and you're gonna say, well, something comma 1 then must have been on the original. Was that hard to do? Super easy, right? They gave me the x on the inverse function of which I'm supposed to find the derivative. So boom, boom. Next you're gonna fill in the other parts. It'll be easy. I'm gonna have you point over here. You're gonna write easy. You will never stress out figuring that out. You are either given it or you're gonna read it off a table. So what goes right here according to this problem? Go ahead and read it. 0. And that goes right here. That's super low stress. All I'm doing is getting my corresponding points. The next thing you're gonna do is hop on the original function and find the derivative there. That's gonna be easy too. Do you know how to take the derivative of a polynomial? I would hope so, right? So my derivative of f, anywhere on f, would be 6x squared plus 5. I did not stress out at all. My point that I'm on, though, is when x is 0. So this is the slope on the original function. And what did I say happens for the slope on the inverse function at its corresponding point? Reciprocal. Guess what the answer is? 1/5. Did I use calculus? A titch. But I'm certainly not using, did you see the delta math with using that whole model, which you would forget anyway? It would get you to 1/5. This is never not accurate. I never teach you a shortcut if it wasn't accurate. I actually call it a smart cut because I think it's smarter than using the other way. This makes sense. So watch the algorithm again. Go ahead and read the problem. I know I have inverses because it's actually telling me with words. And then I'm to find the derivative of the inverse function when x equals 2. So here's my algorithm. Number 1, 2 comma something has to be on that inverse function if I'm to find the derivative there. Done. Bullet number 2, well then something comma 2 had to be on the original, whatever they call it. Like even if you're working with h's and k's, this method is nice because you don't have to memorize a rule. All right, so how am I going to figure out what gets mapped to 2 on f? They didn't tell me explicitly up on the other one, but where am I going to find it? I'm going to go over here to f, and I'm going to find out, well, where is f2? Oh, there's my point. Boom, boom. Did that stress you out? It's kind of just like, oh, it should make sense. I'm hopping on the inverse function and the original. I'm now going to find the derivative on the original at -5. Because I can. What is it? What is it? 3. Yeah. Am I done? No, I'm on the original function, like I'm on x squared. I need to be on root x. But how are they related? They're reciprocals. So f inverse's derivative at its corresponding point would be 1/3. And you're done. I didn't even think I used calculus on that one, right? No, I didn't. I mean, I had to know what that prime symbol meant, but that's about it. Here's an actual AP one. I don't want to give you a shortcut and have you not be able to answer a question on the AP test because I taught it how I'm not supposed to teach it, but I think it makes sense. So watch how it starts. You ready? Bullet number 1. I need to find, oh, by the way, how do I know I'm working with inverse functions? It actually says, which is nice. So G is actually F inverse, right? Here's my X value. So 1 comma something had to be on G. And they told me G is the inverse function, so maybe I'll sort that out. Just so I know, okay, I'm at 1 somewhere, I'm on my inverse function. Well, then something comma 1 had to be on the original. What's that? You will never stress figuring that out. What is it? Yeah, it told me right over there, right? There's my 2 points. So I'm on my inverse function, I'm on my original function at corresponding points. I will now find the derivative on my original. How am I going to do that? Chain rule. Yep. So I said head over here, crank out a quick chain rule, and times 2, correct? What am I going to plug in there? 0. Yep. So I'll go 0, do I have 6? My answer is not 6. If you never flip something, then you did it wrong, okay? So that means on the inverse function, which they're calling G, at the corresponding spot, so I'm going to be here. That's my end game, is to find the derivative here. But I have to get on the original, find its derivative so that I can do what with it? Flip it. What do you think? It's weird notes. Like if somebody was absent and I wasn't recording these and they looked at his notes, they could go, I have no clue what's going on here. But it makes sense. So I want you to try the first one here. These are all past AP questions, by the way. It's always a multiple choice and there's always only one, but exactly one. You will have one. So I've got 4 different formats that it might be in, just so I don't know what one format you'll get, but you will have one of them. Go ahead, give it a whirl, put your pencil down when you're done or stuck. This would be called a tabular stem. And it shouldn't even really be something you need to memorize. You should just kind of get how inverse functions work. There's 2 points where the x's and y's are swapped. And because x's and y's are swapped, the derivatives are flipped. Shouldn't even need memorization, I don't think. Put your pencil down when you're done. And everyone try. This first one might be rocky, but by the time we have 3. Homework will take anywhere from 5 to 20 minutes. So this will finish. Alright, how are we doing? Are we good? Can I start? Here we go. How do I know I have inverse functions? Well, they gave it to me with notation this time. I told you there'll be 3 presentations. They'll either outright tell you these guys are inverse functions, they'll use notation. Then I'm supposed to hop on the inverse function at 4 and find its derivative. So this is where I start. The x value on the inverse function, x value on the inverse function has to be 4, because otherwise I can't get its derivative there. Makes sense. So this is on G, and G is the inverse function. So you always start on the inverse function, then you hop on the original function, but the x's and y's swap. You have to figure out this missing piece, but it's always easy, right? What got mapped to 4 on the original function? You can go ahead and tell me, I know my recording's on, but what gets mapped to 4 on F? -2. Yeah, here's 4 on F, and that was when X was, there's my points. Alright, there's a lot of extra info on that table. That's why you gotta find what you need. I'm on my original function right now, and on my original function, I'm gonna figure out what the slope of the tangent line is there. And I lost the table. So can you guys tell me what it said F prime of -2 is? What is it? 4? Okay. And so I'm on my original function. I'm now going to go back to the inverse function and figure out what the slope is at its corresponding point. What is it? 1/4. Did about half of you get that right? Raise your hand if you had that one right. More than half. Awesome. Now I'm going to change the presentation. Same skill. but in a different format. So no table this time. They're actually telling me what one of the functions is, but the algorithm doesn't change. That's what I kind of like about this method. You do 4 things in a row, no matter how they present the problem or what they call the functions. Again, notation for the inverse. So let's start. I'm supposed to find the derivative on the inverse function at 2. So 2 comma something is on G. So something comma 2 is on the original. What goes in the missing slots? It says G of 2 is 1. I mean, it's right in your face. Right? Done. With the points. Now I'm going to be on my original function. I'm going to find the derivative there. It's a function of x. The x there is 1. How am I going to get f prime of 1? Take the derivative. Yeah, it won't be hard. That's not the point. The point of this is not to take messy derivatives. It's just to know how to find an inverse. So my derivative would be 3x squared plus 1. Correct? So what's the slope of the tangent line on the original function? 4. But I want to be on the inverse function, right? At its corresponding x value. So what's my answer? How are we doing that one? Are we closer to 100%? I'm going to mess with you one more time, 2 more times. So we did a tabular and analytic, and then this is one I call pre-measured goals. Like all the information's in there, you just have to make sure you dump the right stuff into the right spots. So like one of those cooking shows where I've got these bowls and I just gotta figure out what I need to grab. So here we go. Here's my process. 3 comma something is on G, and they told me G is the inverse function. I get on the inverse function. Then I hop over to the original function. So be careful that you grab the correct piece of info. Will I be filling these empty slots up here with 15s or with 6s? That's what I want to know. 6s. Yeah, it says f of 6. So 6 goes into f, spits out a 3. That's always going to be easy to find. Just make sure you grab the right one. I now have my 2 points that I need. I'm going to find the slope on both of them. But it's f that I have the information about. So I'm going to find f prime at its x value. What is it? Is that a -2 over there?
Yeah.
Yes? Now that I have it, I'll go back to the original function, the inverse function, and I'll find its slope or derivative at that point. What's the answer? -1/2. What do you think? We got it down? Okay, it's very algorithmic. It makes sense. It's algebra 2 with hardly any calc involved. So here's our last one. I think I'll just wrap it up. I feel like you're getting it. How do I know these are inverse functions? Because you got to know when to use the skill, not just how to use it. Like if you were taking the AP exam, how would you go, oh, okay, we're working with those inverse functions. The f of g of, yeah, I've got functions undoing each other. So again, I told you, sometimes I'll just outright tell you, sometimes I'll use the little -1. On this one, they told me what inverse functions do. Doesn't matter. I'm going to go over here and figure out what I'm working with. I have 8 comma something on the inverse function. This is the x value on G. G is f inverse. So something comma 8 has to be on f. Agreed? What's going in this slot? It's always easy to find. 3, 3. Actually, I could take these out right now because my G of 8 is 3, right? Now I'm going to hop on which function? Which one do I hop on? I've got my points, I've got 2 of them. Which one do I hop on? F, the original. Yep, because that's what I have information about. If I knew G prime already, I wouldn't be doing the problem. So I'm going to hop on F at 3 and find its derivative. They handed it to me, grab it, right? And then I'll go to the inverse function at its corresponding x value. And that means I reciprocate. Cool. What do you think? You okay with it? So your algorithm is this: point, point, slope, flip. We good with that? Go ahead, hop on delta. It's kind of about the luck of the draw, how long it takes you, because last time the first one done said 8 of his 10 were tabular. takes a little longer if they give you the actual function, because you have to take the derivative, so that's easy.